Okay, so here we have the following problem that says, given that cotangent A is negative 2 over 5 and secant B is negative 3 over 2, where A and B are from the same quadrant, calculate the values of the following without the use of calculators. Show all solutions. We have to find tangent A, cosine A, cosecant B, and sine B. Okay, so let's digest the information given in the problem. First, what we know is that cotangent A is negative 2 over 5. So let's write that down. Cotangent A is negative 2 over 5 and secant B is equal to negative 3 over 2. So note that we are talking about two different angles here, namely A and B. The only thing that connects these two angles is that they are both from the same quadrant. Okay, so we need to find, or we need to identify what that quadrant is. Okay, so how do we identify that quadrant? Let's take it from these two information. If cotangent A is a negative number, that means that tangent A is also a negative number. If the secant B is a negative number, then cosine of B is also a negative number. So they're both less than 0. Okay? Take note, those ideas came from the relationship that these functions are reciprocal of each other. Cotangent is the reciprocal of tangent. Secant is the reciprocal of cosine. So if they're just reciprocal of each other, then their signs must be the same. So cotangent is negative, tangent is also negative. Secant is negative, cosine is also negative. Okay, so using this new information that we have, if tangent A is less than 0, then that could only be in quadrant 2 or in quadrant 4. That's what we learned from CAST. And then if cosine B is less than 0, that could only be at quadrant 2 and quadrant 3. So as we can see, the only common quadrant that these two angles are sharing is quadrant 2. Okay? So the angle, or the angles A and B, will be constructed in quadrant 2. Okay. So let's proceed. So let's connect what we have now. Let's talk about angle A first. So if angle A is located on the second quadrant, we can create a right triangle. So if this is A, then this is the triangle that we can create. Now since it says that tangent A is negative, or rather cotangent A is negative 2 over 5, this means tangent A, being the reciprocal, is negative 5 over 2. And we learn that tangent is opposite over the adjacent. So if we use the triangle here, so what we can have is that this side can be the 5. Let's take the positive measure first. This is 5. And then adjacent is 2. Now it's up to you if you want to consider it already as negative 2. So this is at negative 2. Or you just retain 2 and work on the negative number later. So this is at 5. Okay, so if we have 2 and 5 as sides of a triangle, we can find the third side using the Pythagorean theorem. So if we use a standard equation for the Pythagorean theorem, a squared plus b squared equals c squared, we can have 2 square plus 5 square is equal to c square, since c is the hypotenuse. Then 2 square is equal to 4, 5 square is equal to 25 is equal to c square. So this is 29 is equal to c square. This implies that c must be the square root of 29. We are now disregarding the negative square root of 29 because it is a side of a triangle. Okay, so we can now label the hypotenuse as square root of 29. Okay, so these are the things that we need for angle A. So what about for the angle B? So for the angle B, we construct also the angle B. So this is angle B. We create a right triangle. And let's take some information coming from the problem that says, so it says here, the secant of B is negative 3 over 2. Okay, so if the secant of B is equal to negative 3 over 2, then the cosine of B is equal to negative 2 over 3. Again, remember, they are reciprocal of each other. So, since cosine is adjacent over the hypotenuse, we could consider the side here as 2, and this is the hypotenuse 3. So we're missing one side. Okay, so again, using the Pythagorean theorem, a square plus b square equals c square. This time, one of the sides is missing. Let that a to be the missing side. So you have a square plus b is known to be 2 square is equal to c square. We already know c, so that's 3, so we can have 3 square. So a square plus 4 is equal to 9. A square is equal to 9 minus 4 or 5. That gives us a equals the square root of 5. Again, we consider the positive number. Okay, the moment the triangles are complete with all the sides that we need, it will be easier for us to find the values that we're looking for. In letter A, we're looking for the tangent of A. Okay, this will not require the triangles anymore because cotangent is the reciprocal of tangent. So if cotangent is negative 2 over 5, then this must be negative 5 over 2. For letter B, we wish to find the cosine A. So in this case, we'll be using our triangle here. So this is our triangle. So we're looking for cosine A that's adjacent to, so see here, that's adjacent to over the hypotenuse square root of 29. So we have the adjacent to over the square root of 29. Note that the angle A is in the second quadrant, so this must be a negative 2 over the square root of 29. Again, if you already considered the negative 2 as the side of the triangle, okay, just the value, of course the side should always be positive, just the value, negative 2, then you can immediately have the negative 2 over the square root of 29. Otherwise, after finding the 2 over square root of 29, you have to consider in which quadrant the angle A is located. Okay, so this can be further be simplified by multiplying by square root of 29. So this is negative 2 square root of 29 over 29. And from here, so this is no longer, or this is already in the simplest form, so we can leave the value in this way. Okay, letter C, what we wish to find in letter C is, so let's look at the problem again. We wish to find cosecant B, and later on the sine B. So if we want to find the cosecant of B, we go to the triangle that we created for angle B. Okay, so cosecant is the opposite of sine. Okay, so might as well find the sine first because that's letter D. So sine B because cosecant B just depends on sine B. So sine B is opposite over the hypotenuse. So we consider the triangle for P, the opposite being square root of 5. The hypotenuse is 3. So we have sine B as square root of 5, square root of 5 over 3. Then the cosecant B is 3 over the square root of 5. Now take note that B is in the second quadrant and sine is positive in the second quadrant. So these values should be positive. Okay, to end with the cosecant B, we can simplify this by rationalizing the denominator. So this will become 3 square root of 5 over 5, and that is the simplest form. So here, we were able to find all the values that we need. Okay, so what are the key ideas in solving a problem like this? First, you need to identify where the angles are located. So this can be located by using the information given in the problem. In this case, we have cotangent A to be negative 2 over 5 and secant B to be negative 3 over 2. Then you have to work on the reciprocal, cotangent for tangent, and then cosine for the secant respectively. Okay, and then after that, all you have to do is to create the respective triangles. So in this case, we have A, and here we have the B. Please recall that the Pythagorean theorem says a squared plus b squared equal to c squared, which is needed when you find the other side or the third side of the triangle. Okay, then from there, all you have to do is to work on the SOHCAHTOA for the tangent A, cosine A, cosecant B, and sine B. Here, tangent A is a bit special because you don't need a triangle anymore because cotangent A is given, so all you have to do is to just get the reciprocal of cotangent. Okay, so that's how you solve this problem. If you have any, if you're confused on some parts of the video, all you have to do is watch that part again and hopefully it will be clear the second time around. Okay, so that's all.